Hey everyone, welcome back, and today let's solve LeetCode problem 983 titled Minimum Cost for Tickets. So we have planned some train traveling 1 year in advance, and the days of the year in which we will travel are given as an integer array days. And each day is an integer from 1 to 365. That doesn't mean all the integers from 1 to 365 are going to be present in our input array. That just means that that's the range that our input integers in that array can be in. So train tickets are sold in three different ways. The first way is that a 1-day pass can be sold for costs at index $0, where cost is actually another given input array or parameter. And a 7-day pass is another alternative, which is sold for costs at index $1. And finally, there is a 30-day pass that covers 30 consecutive days that is sold for costs at index $2. So the passes allow that many days of consecutive travel. Very important to note here, it has to be consecutive. So that, in other words, that means the days that we're going to travel using that number of days pass have to be consecutive or adjacent. So for example, if we get a 7-day pass on day 2, from day 2 up until day 8, all the days in between in that consecutive range for those 7 days, we can travel on those days using the cost or price of that 7-day pass as a choice. Right? And we need to simply return the minimum number of dollars we need to travel every single day in the given list of days. A very important word to note here is that we want to return the minimum number of dollars, right? This is actually an optimization problem, and usually optimization problems, when we want to find the maximum or minimum of something given some constraints in a problem, usually leads to dynamic programming. So I won't say too much about the algorithm that we're going to use yet. Let's just go ahead and look at the examples for now. So in example 1, as you can see, our input array days is the following: 1, 4, 6, 7, 8, 20. And our costs input array is 2, 7, 15. Another thing to note here is that the cost input array is always going to be 3 for every test case. The reason why is because we're always going to have exactly 3 different possible tickets, or rather 3 different possible passes to shop on specific days. We can have the 1-day pass, 7-day pass, or the 30-day pass. We're only always going to have exactly 3 of them. And for our input array days, we have the following, and their costs are going to be 2, 7, and 15. What that really means is that we want to travel on days 1, 4, 6, 7, 8, and 20, and the costs for a 1-day, 7-day, and 30-day pass are $2, $7, and $15 respectively. So in this case, our output is 11 because that is the optimal minimum number of dollars that we need to travel through every single day in this given list of days. And in the explanation, you can see that, for example, one way to actually buy passes that lets you travel your travel plan, that lets you cover all the days in this given range of our input array days, on day 1, so here, we can buy a 1-day pass for costs at 0. Which would basically cost $2 because cost at 0 is equal to 2. And that's going to cover just day 1. Now, on day 3, we can then buy a 7-day pass for costs at index 1. That represents the price of a 7-day pass for $7. And on day 20, we can then buy a 1-day pass for costs at index 0 to be $2, and then we can cover $20. And so in total, covering all the days in this range, we can spend a total of $11 and cover all the days of travel. And all the days of travel, again, are these specific days in our input array days. In example 2, we have our input array days to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 30, and 31. And in this case, our costs is still the same of 2, 7, and 15. But in this case, since we have a lot more specific days to actually cover, in this example, our output also increases because that is the minimum number optimal of dollars that we need to cover or travel on all these days from specific passes in our input array costs. So one way we can buy these passes that lets you actually travel our travel plan covering all of these days of traveling. On the day 1, we can buy a 30-day pass for costs at index 2, which would be $15. Then we go all the way up here. And then finally, on day 31, we can simply buy a 1-day pass for that specific day, for that just day 31, which would be another extra $2. And so in total, 1 to 30 in this range would give us a $15 price. And then for this day 31, this singular day, that would simply be a 1-day pass, which would just cost an extra $2. And so in total, we would spend 15 plus 2 or $17 to cover all the days of our travel, specifically and optimally using passes from our input array costs to cover all of these days. And for the constraints, we see again that the length of our input array days is not going to exceed 365 because we know there's only 365 possible days to even cover because that's how many days are in the year. And of course, we don't care about duplicates. And we know that the length of our input array costs is always going to be exactly 3, and it is going to be in strictly increasing order, which is also pretty helpful. So with these examples and constraints and problem statement out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution. And then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so what is one key observation we can really make in this problem? Well, the key observation that we can kind of take away to help lead us to our solution is that this problem really just has overlapping subproblems. And when you think of subproblems, what do you think of? Well, you think of dynamic programming. So for instance, to calculate the cost of traveling on day I, well then we may already have calculated the costs for earlier days, right? And that is a perfect scenario, again, for dynamic programming. We can rely on previous computations to help calculate the current operation, right? That's how dynamic programming kind of works. Usually it's incremental, right? So basically what we're going to do is we're going to define a DP array where DP at index I is going to represent the minimum cost of traveling up to day I, or index I. And we're going to be using a greedy approach to decide whether to use a 1-day pass, a 7-day pass, or a 30-day pass for each day in each iteration optimally. So just to comment that out for reference as we actually code up the solution, DP at index I, let me actually put a space there. What DP at index I is going to really represent is it's simply going to be, or rather I should say represent, the minimum cost, because that's exactly what we're trying to minimize in this problem, the minimum cost to travel up to day I, right? And really, I guess it's index I for this array. Doesn't really matter though. What you really need to understand is that it's going to be for day I up until that point in our input array. Okay, so effectively, for the kind of data structures and variables that we're going to be using to solve this problem, we're going to have actually a set of travel days. And the reason why we have a set is not because of duplicates, because what we really want to use a set for is that constant lookup time. Right, we want to quickly check if for a particular day is actually a travel day that we want to actually travel on and cover. And we're also going to use, again, like I talked about before, a DP or dynamic programming array to store the minimum cost up until each index or day I. And then the costs array, which is simply going to contain the ticket prices for each pass, the 1-day, 7-day, or 30-day pass. So effectively, again, we're going to iterate over all the days of the year, calculate the minimum cost for each day, if it's actually in our days, and then build our solution dynamically. Okay, so with that kind of high-level rundown out of the way of the solution, let's go ahead and dive straight into the code here. So what I'm going to do first is initialize my travel days to be a set of the days. Sorry, I don't know why I typed a 0 there. It's going to be a set of our input array days, right? Two things here. Really, the first thing isn't really too important. The first thing here is that we don't really care about duplicates. We want to erase all the duplicates. And the second thing here is that we want to have a constant lookup time to check if a current day is actually in the travel days, right? Otherwise, we can just continue. We don't care about the day if we don't have to travel on that day. And to look if it's in this data structure, the set data structure is very, very helpful because it has a big O of 1 or constant time lookup time, making it very, very efficient to actually quickly check if a given day is in a travel day, right? And we're just storing all of those travel days in this specific set that we call travel days, okay? Once we've actually initialized that, now let's actually initialize our DP array that we're going to actually store the minimum cost up until every single index I or day I is. So I'm just going to call it DP. It's going to be initialized to all zeros, and its length or dimensions is simply going to be days at -1 plus 1. Why is it days at -1 plus 1? Well, first of all, we're given the fact that days is in strictly increasing order. So we know the largest day is going to be at the last index. Or in other words, the final day that we have to travel is going to be at the last index. So the size of this array is simply going to be the last travel day from that day's array plus 1 to make sure that every day up until the last travel day, or in this range, it's actually accounted for, right? That's going to be the dimensions of this DP array, right? So now let's actually loop through our days and actually basically check if it's in our travel days and compute if it is the actual minimum cost for it. So for every single day in the range of 1 up until days at -1 plus 1. The reason why I'm doing plus 1 is because for loops in Python are exclusive, and so we want to go up until days at -1. And so this plus 1 simply just counts for that offset here for loops in Python. Again, here, pretty straightforward. It's really just a simple for loop here, looping through every single day from day 1, because of course this is 1 indexed up until the last travel day. And even non-travel days are still going to be processed because we want to actually maintain continuity. So the first thing that we want to do after we actually iterate over all the days in that range, we want to first handle non-travel days. So if the current day that we're iterating over, if it's not in the travel days set, this is where the constant big O of 1 lookup time comes into play. Well, if that's the case, then we know that DP at day is this, DP at day is going to be the same thing as DP at day -1. Right? Because we know it's not in the travel days. And then once we actually set that or update that index, we simply want to continue. Because we don't care about this day, it is not in the travel days. And what we're really doing in this conditional here in these 3 lines is, again, if the current day that we're iterating over, if it's not a travel day, if it's not in our travel days set, then the cost is going to remain the same as the previous day for that day. Because no additional tickets are needed to travel on that day. And so we can simply update its indice accordingly at that index, and then skip on to the next day or continue on to the next iteration for the keyword in Python. So this is the main chunk of the code. Now we're going to enter the main chunk of the code for the dynamic programming solution. It's going to be actually calculating the minimum cost for the travel days using our 3 choices that we have, either the 1-day, 7-day, or 30-day pass. So if DP at day is actually in the travel days and we haven't already continued in this iteration in this for loop here, well then we want to set DP at day to be the minimum cost possible. So it's going to be the minimum, and let me actually just go down a little bit here. It's going to be the minimum of the 3 choices we have. So the first choice we have, the first choice we have is DP at max of 0 or day -1 at that index plus costs at 0. So I'm just going to add a plus costs at 0. And this is if we use the first 1-day ticket. The next choice we have is using the 7-day ticket. So that's going to be the maximum of 0 and day -1 still. Or rather, sorry, day -7. Sorry about that. This is the 7-day ticket. And then we're going to add on, instead of costs at 0, costs at index 1. Because that's the price of the 7-day ticket like they told us in the problem. Right here it's the 1-day ticket, here it's the 7-day ticket, so we go day -7, and we go costs at index 1. And the last choice we have is simply going to be DP at still max of 0 or day -30. Oops, I don't know why I keep missing my comma here for an M. And we're going to add on, in this case, you probably guessed it, costs at index 2, because that's the price of the 30-day ticket. Let me just go up real quick here. Okay, that should work. Okay, so this is kind of, again, the main chunk of the dynamic programming minimum cost optimization solution. What we're really doing here is simply calculating the minimum cost for this current day based on our 3 choices from the cost price at that specific ticket. So if the current day, again, if it's actually a travel day, then we have to actually calculate that minimum cost. What this first does, as we're minimizing it, what this first on line 11 really does is we have to basically just, the cost of a 1-day ticket, we have to basically add it to the cost up until the previous day. This is pretty similar logic here. It's going to be the cost of a 7-day ticket that we add up to the cost up to 7 days ago. And here, this is going to be the cost of a 30-day ticket that we add up to the cost up to 30 days ago. And we're going to use the max of 0 and day minus blank, day minus x, to basically make sure that we don't go into negative indices. So if this is lower than 0, well then we're going to just take the max of it, in this case 0, so we don't go out of bounds and hit a negative index. right? And effectively, once we're done calculating the maximum, or rather, I should say the minimum of all three of these choices here, picking a 1, 7, or 30-day pass up until 1, 7, or 30 days ago for that specific cost, effectively, once this for loop is actually done terminating, or rather executing, once it terminates, we simply want to return the result, which is going to be stored at DP at days at -1, because that's the last day or the final day up until we travel to, right? That's going to contain the minimum cost to cover all the travel days up until the last day that we have to travel, which is stored in days at -1 because we know it's in strictly increasing order. And so at that point, we simply have to return that specific value. So unless I made any syntax errors here, this should be accepted and this should be a valid solution. And as you can see, this is really just about as efficient as you can get it to be. So for a quick high-level rundown here of how the code actually works, basically, we're just using this dynamic programming solution and this dynamic programming array to calculate the minimum travel cost up until each index or day I. So effectively, we're iterating over all the days and then calculating the cost for travel days using our 3 ticket options. And we're building up the solution for each day step by step based on previously computed days. Right? And basically, by the time we actually reach the last travel day, once the for loop is done executing, we would have had the minimum cost that's stored in DEP at days at -1, the final day that we have to travel up until, right? So for the time complexity of this solution, this is going to be a big O of D. Runtime complexity, D is simply going to be the range of days from 1 up until that last travel day. And the reason why is because straightforward, this is still really just a one-pass solution. We're going to iterate over every single day exactly once from 1 up until the last day, which is, again, day at -1. And the space complexity is also going to be big O of D because we actually store that DP auxiliary memory extra data structure, which is going to have a size of big O of D. That's literally how we initialize it with those specific dimensions. It's going to have a size equal to the last travel day. Right, so really, you can also say it's big O of n for both the runtime and memory complexity. That's a formal kind of notation for it. But big O of D really also works because, well, that's how I kind of suggested the last day was called, right? I just called this last day big O of D, or I guess D, right? So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.